Hey guys, and what's up, and welcome back to my channel. Today I'm going to be talking about today's LeetCode challenge sum, which is the maximum level sum of a binary tree. The maximum level sum of a binary tree. Given the root of a binary tree, the level of its root is 1. The level of its children is 2, and so on. Now, we need to return the smallest level x such that the sum of all the values of the node level x is maximal. So we got him this as the root node. So this is level 1. The children's are going to be the second level, and if the children split into further, then that will be third level, and so on. So each time a node is split, each level it's taken 1, 2, 3, like that. Now we need to find the maximum sum from each level. So when you go through the first level, the first one sum is 1. The second level, the sum is 7, and the third level is -1. Over here, if you know that immediately by just seeing, you can tell that this is the maximum sum. But we need to know that. So we need to return the level which has the maximum sum. So this one the second level has the maximum sum. So we return 2 as our answer. In this, you might have noticed two words. Return the smallest level x such that the sum of all the values of the node at level x is maximal. What does that mean? For example, over here in this example, we have the same node, 7, 0, 7, 0. Now we got 1, we got the sum of the second level to be 7, and the third level also 7. But we need to return the minimum level. So 1, 2, and 3. The second level is the minimum. So we return 2 as the answer here as well. I'm going to code this problem. And once we code this problem, we will dry run this as well. The first thing I'm going to do is use a queue data structure. Now this queue, the data type of this queue is going to store the 3 nodes. It's going to store the nodes, not their actual values. And you need to remember this. It's very important to remember. A tree node consists of a value, a left node, and a right node. I'm going to name the queue as queue is equal to new. Now this is going to be a linked list. Okay, this is actually a linked list. Now after this, you need to add your root node directly to the queue. Okay, don't leave it empty. Directly add the root node, which is passed over here at your function. You get the root node directly, so you can just add that immediately to your queue. Now your queue will hold the root node, and you need to remember that we need to have 3 values. Okay, the first value is going to track the levels. The second value is where we will store our answer. So this level is also initialized to 1. Okay, we will change the answer level inside our code. Next, we will have our max sum, the maximum sum that a level can produce. Okay, integer dot mean value. All right. Now that we got it all ready, it's time to enter the next code. The first thing you need to make sure is your queue is not empty. And remember that you can have empty values as well. So maybe if there is no root, then it's going to be empty. So while your queue is not empty, you can go ahead inside the while loop. Now what you're going to do, the first thing, it's the most important thing, we are going to find the size of your queue. Okay, so I'm going to have a variable and I'm going to find the size of my queue. The reason that I'm finding the size of my queue is I need to know how many nodes that I have for a level. For example, over here in this level exactly I have 2 nodes. So when the size is 2, I can stop my calculation exactly at 2. Okay, otherwise the queue might have more number of values as well. We will know why that is soon. So the queue does not guarantee always to have the equal number of values that your level has. I will tell you guys why it is. Okay. Now that you find the queue size, you need to make sure you have a sum as well. Now this sum is what it's going to calculate the sum for each level, not the maximum sum, but it's going to calculate the sum of each of your level. So we are initializing it inside the while loop. Now that we initialized it here, I'm going to use for loop. Now we're going to go through each node. We're going to visit each node at least one time here. So we're using a BFS approach. So this BFS approach is really helpful because we can visit each level, all the nodes at each level. So how does a BFS traverse? A BFS traverse using the root node, it traverses its left and then the right. So you exactly visit your left, right. So you exactly visit the entire level of the node, making it the best traversal method to go through this tree and calculate the sum. So I'm going to have int I is equal to 0, I less than the size, and I plus plus. Now inside the for loop, you need to go and create a new node. This node is going to store the value of your, this node is going to store the node that you're currently in. Okay. All right. Right. So over here, after you pull out the root node or whatever it is stored inside of it. Now that you know the node, you need to calculate the sum. How do you do that? Node dot val. Node dot val or value. Wait, I'll take it up. Yes, val. So this is the value of that node. A node can have value. It can have their left and right nodes as well. So you're going to take the value out of it and you're going to sum it up. Once you got the sum of it, now you're going to check whether you have a node dot left, whether you have it or not. Now if you have a node dot left, you will have it as null. You will not have it as null. Or if you have a node dot right, you will not have it as null as well. Now once you know that you have a left and a right value for that node, it is really important that you add your left and right values as well. So you need to go ahead and add q.add. You need to go and add the values. And over here, I just go and add q.add. Now I go and add node.left. Make sure you need to add only 3 nodes. Okay, make sure you do not add anything else. Okay, you need to add it as a whole, as a node. Okay, so this consists of only the nodes, not their actual values. Okay, to extract the value, you need to write node.val. So once we included the node.right and left, we added to the queues as well. it is time to go ahead and find out your sum. If your sum is greater than the max sum. To do this, you cannot do this inside the for loop. You need to come out of the for loop. The for loop is only for adding your nodes left or right, if you have any, to the queue, okay, and calculating the sum for each level, okay. So once you do this, now that you have it, you can go ahead and you can go ahead and calculate the sum. If your sum is greater than, we have the max sum. So if it is greater than max sum, I will simply go ahead and say that my max sum is now the current sum. And also you need to remember that you need to update your answer level, because that level is having the maximum sum, okay. So once you complete all this, you need to remember that you need to do a level plus plus, okay. You need to upgrade your level, meaning that once you update your maximum sum, you have finished calculating that level and you need to upgrade it to the next level, okay. Once you do that, and once your while loop is completed, you can simply go ahead and return your answer level. Right now, let's go ahead and try run the problem. Over here, we got the first thing. We need to add the root value to the queue. Over here, we got 1 as the root node, so we are going to add that to the queue. The next step will include us to find the size of the queue and also making sure that the queue is not empty. So the queue is not empty, so we need to find the size of the queue. So the size of the queue is going to be 1, meaning that this current level has only 1 node. Now that we found the size of the queue, it's time to sum the problem. So we go ahead and add that value to the sum. Okay. So 1 it will be the sum. Sum is equal to 1. And remember that I will go only till 1. Okay. And how do you take the value? You need to poll. So once you do polling, it takes up the first value from the queue and leaves the queue empty. So once the queue is empty, we take up the node and we store it in a variable called as node. So inside the node, you will have the node value 1. Node.value will help you to give the value of the 1. So you need to remember that each node consists of 3 things. One is their value, and if they have a left or right nodes as well, they do have their nodes address as well stored. Okay, they have their node address stored as well. But if they do not have the nodes, they have it as null. All right. So over here, we go ahead and pull the value and we sum the value. So currently the sum is going to be 1. Next, once we found the sum, we shouldn't lose the node, right? Because we already took out of the queue. We do not have that value in the queue, and we only have it inside a variable called as node. Now once this for loop is done, the node value vanishes. That means we can no longer have the node value, and it is going to keep on changing, right? So to avoid that, we pick out the left values and the right values as well from the root node before we end the for loop. because right now we got the sum of the first level. It is done and dusted. We got the uh, first sum value from the first level. It is going to be ending now, but before we end it, we're going to pick out the left and the right values as well. So I'm going to quickly add them to the node, and these nodes to the queue. So node.left will be added to the queue. So 7 is going to go inside the queue. Next, if node.right is also not equal to null, that means if you have a value on the right side as well, you're going to add them as well to the queue. And remember, queue follows first in, first out. So when you're pulling out, you pick out the first value on it. Now that we have reached the end of the for loop, we come out of the for loop. And right now we go inside to find the sum, the maximum sum. After we finish summing up one level, we summed up the root, we got 1. We find the maximum sum is greater, whether the sum is greater than maximum sum. Yes, it is. So the maximum sum takes the value of 1, and the current answer level is also 1. And we do level plus plus, so it is 2 now. In the second level, we go through the while loop again. We go and check whether the queue is empty. It is not, because we got here 2 values. One is 7, another one is 0. Now we go ahead and take the size of the queue, that is 2. That means your second level has 2 nodes. Now we initialize the sum back to 0, and now we go inside the for loop, making sure that the for loop is going to, oh gosh, okay. So making sure that the for loop is going to run till 2. Now we go inside and we go and take the value node is equal to q.poll. Now when we extract out, the queue will only have 0 and 7 node. The node 7 will be stored inside the 3 node. Now that we take the node.well, we add 7 to the sum. So currently your sum is going to be 7. Your sum is going to be 7. Now that our sum is 7, we go and check whether they have a left node or right node. The reason we do this is, once again, when we come back to the for loop, we're going to have only 0. And we always make sure that we do pick out our left and the right values before we take out new values from the node. We go ahead and check, and 7 and -8 are the values. Now what advantage this queue gives is, once you go to node.left, you add your node.left to next of 0. So you go and add 7, and then node.right is also not equal to null. That means you do have a node.right. So that is going to be -8. Now we still didn't finish the iteration because we just completed I is 0. Now when I is plus plus, we get I as 1. Now that we go to the tree node, we do q.poll that removes the 0 from the queue. Once you remove 0 from the queue, you add to the sum 0. And now that your sum is 7, you go and check if 0 has any left or right nodes. You can see over here that the left node.left is null, so it will not enter into the if condition. And node.right is also null, so this will not also enter this if condition. Now both of them they don't, so for loop is over and it goes to sum greater than max sum. Now your sum is 7 and it's actually greater than 1. So your max sum is updated to 7, and answer level is also updated to 2, and your level plus plus will go to the next level, which is 3. Now we go to the while loop and check whether the queue is empty. It is actually not empty. Now your new queue is 7 and -8, and the size of your queue is 2, and sum is 0, and your for loop is going to run from 0 to 2. In q.poll, we go ahead and poll, and when we poll, we actually get the value 7. So right now you're going to sum This is going to be a fresh sum. I'm writing it over here, 7. Next, we go ahead and check whether they have a left node or a right node. And your 7 does not have a left as well as a right node. So you go and do another for loop. The for loop is still running. When I is equal to 1, we go ahead and see the q dot pole. So the 7 is removed, so we have only -8. So now that we do sum plus is equal to 7 minus 8, we get -1. We go ahead and check the left side and the right side of -8, and it is actually null, so we don't enter into this if condition. Once we complete the for loop iteration, we enter into this if condition over here. Inside the if condition, we go ahead and check whether the sum is greater than max sum. -1 is not greater than 7, so we don't do any changes here. And we do level plus plus, which makes it 4. And then we exit this while loop. Because the queue is now empty, we don't have any values inside the queue. Then we go ahead and return the answer level, which is currently 2.